pancake bowl, teriyaki chicken, beef sub crispy chicken salad, Spartan grill, spicy chicken sandwich, and practice starts today. So, we'll be picking up wrestling banquet, 19 pounds at 5:30. National Running Society, Drive on March 24th, 10 a.m. to 3:30. They'll be parking in the parking lot. Fine if you're 18. Go out. 17-year-old Whitenberg, sign up and donate. You will not be allowed to use class other than sports. The lunch is off the house art show tomorrow. In this full tradition house with any questions. All winter sport athletes. 40-year-old basketball players will the auditorium today at 1:45. That's the beginning important time to complete the end of the year survey. Mr. Nellius, athletes, make sure you bring your computers. Those that are not required to be important time to be dismissed, then the rest of you will go back. Seniors, John Gill, congratulations, speaker that on Wednesday of this week. Your sophomore and junior, you're up to the leader. Should be. Check out information on the announcement page. Seniors, your cap gown and other items here today. 11 o'clock to 12:30. Sure you have not paid, your repairs are being paid and remain balanced. Here's your Steinhardt Booster Music Matters dinner in concert tomorrow night. Pop concert begins at 7. Nacho bar begins at 5:30 in the Commons. $5 for that meal. Come enjoy a night of music.
Were there any allergy kids in here?
Spartan Athletic Booster Club scholarship forms.
No.
You pick them up.
Okay.
$100 to end of the third quarter is a day of Wednesday. Plan accordingly. Great to be posted next week. No school Thursday, Friday this week. Spartan Lecture of the Week, Nick Van Deep, Tommy Anglin. Both did a tremendous job. Here's the three-season track man. The show now is the start of the race trial. All for you. To the flag.
Getting this right by working with your neighbors does you no good for your tests. Yeah, that's mush. Before we get on to the daily quiz and lesson, naturally, we must consume. So, notes from the chef. A. She was assisted by recalcitrant toddlers, so if it sucks, deal with it. B. The rhubarb is from my mother's garden, and she takes no responsibility for whether the rhubarb was decent or not. Plates there, forks there, napkins there, scooper for each one. Those two are fine with just forks. We have apple, cherry, lemon meringue that did not have enough meringue, so it kind of like shrunk. We have rhubarb, French silk, grandma's pumpkin pie that was specifically made for the unidentified autistic kid in the 90s who could not handle pie. You can pick it up and eat it like a slab of brownie. It's great. And chocolate chip cookie pie, which is basically a big friggin' cookie for people who hate pie. If there's anyone who has allergies and is allergic to everything, there is a strawberry marshmallow jello thing that is in a pie tin, so we pretend it's pie. Ladies first. Also, these 7 only represent half of it. There's another like 7 or 8 in there. So, Mama Bear banged out about 14 pies in 2 afternoons. So, Come on, Frank. Wake up. She's particularly interested to know if the French silk one turned out okay. That was her first time making it.
It's really good.
So, as everyone's getting their food, we're just going to kind of roll through this. We have 2x plus 2 plus x minus 4. Okay, for those who are not grabbing food at the moment, yes, gentlemen, you may go. When solving a nonlinear inequality, the things that we look for are zeros and asymptotes. On a number line from negative infinity to infinity, I know I'm going to have asymptotes at -1, +4, and there will be an x-intercept at 2/3. I can sketch out the graph if that's my jam. Just real quick, say there's a thing there, there's a thing there, there's an x-intercept there. If I plug in 0, what is that? -2 over -4 is +1/2. Horizontal asymptote at 0. So I could just kind of quick sketch it using the behavior. I could look at my screen. I could make my number line and then just plug numbers in to test the intervals. I can do any of the above, and I will discover that negative, positive, negative, positive. Okay? And it asks, where is this thing greater than 0? So it's going to be everything from -1 to 2/3, union everything from 4 to infinity. Assuming I got my behavior right, but that should be correct. So that's it. There was no or equal to. If I was thinking, I would have made that greater than or equal to just to trap you. Remember, if you're at a x-intercept, it can have a bracket because it's equal to, but even if it hits the value, it's not equal to at an asymptote, so we'd have to use parentheses there. But I'm looking for, did you get your asymptotes? Did you get your x-intercept? Do you have the test shown? Did you have the final answer? And then we'll leave one somewhere back here for the work because we all know sometimes we miss a negative. Sometimes we say -4 plus 2 is -6. We do the oopsie. Okay. So 5 things, 5 points. Unless you got a question about it. So what's the verdict on them? They decent? Okay. All right. Homework. I cannot remember over the last 4 or 5 days if anyone asked questions on it, but 36. Womp. Come on. 28. Come on, you. 32, 33, 34, 35, 36. Oh! 36 is a lot easier than you think it is. Where is f of x minus g of x greater than or equal to 0? If I were to just add g of x to both sides, where's f of x bigger than g of x? F of x is above g of x here and here. That's it. From negative infinity to negative 1, bracket, because it says or equal to, union, 2 to infinity. That's it. They're just seeing if you can do it graphically as well as algebraically. Understand that f of x and g of x are the outputs of a function. Outputs are y's. Where are these y's minus those y's going to be positive? Well, that happens when they are bigger. So you just see where it's above that line. What else? See, first hour y'all normally zombies, but boy, can we tell that daylight savings happened this weekend. Room full of 24 kids going brains. Okay. Nothing else? Did everyone get your packets on Friday? If not, they're in the bin back by the door. Again, anytime there's something physically handed out, it'll always be in that bin. Okay. So, last time I was okay doing a test after 4 days instead of 5 because I didn't want to split 2-5 around either side of the test. But this time I got no problem starting 3-1 and then the test tomorrow because, y'all, 3-1 is not tough at all. In fact, chapter 3 is going to be one of the easiest that you do in the course because it's all review of exponential functions and logs, which you just did in Algebra 2. We just kind of take where you left off and just click it up one notch. That's it. So we start with exponential functions. What are they? And people will incorrectly interchange the terms exponential function and power function. They are different. See, an exponential function is when I have a variable in the exponent. Power function is when the variable is the base. So this exponential, this power. And because maybe we haven't been as diligent using our vocabulary in the past, sometimes we'll just interchange power and exponent. So maybe it's important to remember that this to the this equals the this. What are those three things called? Okay. What goes here? Base. Yeah. What goes here? Well, yeah, for exponential functions, it's the exponent. And if I take a base to an exponent and then evaluate it, I get the what? Hour. Okay, the power. Okay, so for example, if I say 4 to the third is 64. 4 is a base, 3 is an exponent, 64 is the third power of 4. Okay? So we just got to be careful with our vocabulary as we're working through those. Notice that when they have exponents or examples of these, it can be nice. You might have fraction. You might start monkeying around with it. There's different ways that we can play around with those. Please tell me that you all know your exponential rules. X to the A times X to the B, what do I do? If I take X to the A to the B, if I take X to the A, Y to the B, all to the C. Okay, it's like distribution in that they both get that power. X to the AC, B, Y to the BC. Okay. Negative exponents. Reciprocal heads downstairs and loses the negative. It's like a light switch, though. It works in both directions. If I have 1 over x to a negative power, it comes upstairs, loses the negative. Okay, how many times have you been said, you're crabby, go to your room? You're crabby, go downstairs. I hate being around you people. I'm going to go to my room. As soon as you go upstairs or downstairs, wherever the people aren't, you're happier. You're more positive. Okay, it's just like a light switch, up or down. What else? If I have x to the a over x to the b, what do I do? Okay, it's x to the a minus b, and the reason for that is because I can bring this upstairs and it becomes a negative b. And then when I add exponents, well, adding a negative is subtracting. Okay? What else? One. Anything to the 0 power is 1. What?
I still would like to know if the x to the third is outside or inside the radical. I need to know.
It's in, actually.
What do you think? It is in, otherwise I would have that a little bit up. And personally, I would always put parentheses around it. Okay. So just remember your exponent rules because they're all going to come into play here. I said chapter 1 was how do I analyze a function. After that, every time we talk about anything, we're going to start with can you analyze it? So these two, I want to get the graphs and then we'll just do them verbally. When I say 3 to the x, I have been, for those veterans of Algebra 2, I pound on this from Algebra 1 upwards. You should know your squares through 20, cubes through 10, fourths through 5, as many powers of 2 and 3 as you can memorize. What's 2 to the 5th? No. 32. Close. Okay. What's 7 to the 3rd? Yes. 343. Okay, you should just know these things because just like when you first learned to factor quadratics, knowing your multiplication facts is what set you apart from your peers, not having to guess and check on a calculator over and over. Knowing your powers is going to help you with all of this. So, when I say 3 to the x, I can do that kind of by table in my head. It's powers of 3. 3 to the 0 is 1. Anything to the 0 power is 1. 3 to the first is 3. 3 to the second is 9. 3 to the third is 27. is 81, is 243, is 729. It just keeps going. I don't need all of those. And when I go in the other direction, when I say 3 to the negative first, don't use decimals because that's 1 over 3 to the first. If I say 3 to the negative second, say it's 1 over 3 to the second. So instead, just keep using those powers. 1/3, 1/9, 1/27, 1/81. So I see that it is never actually going to hit 0. Okay? Back in Algebra 2, we called them creeper functions. Okay? That kid hanging out in the bushes outside your living room. He's creeping, he's creeping. He's just staring at you. It's really awkward. Oh, they spotted him! And he takes off. Okay? Hint, hint. Kid who stalked Miss McCreary when she was my student teacher. Oh, yeah. So if I say 2 to the negative x, so that's 1/2 to the x. So 1/2 to the first, 1/2 to the second is 1/4. 1/2 to the third is 1/8. Is 1/16, is 1/32, is 1/64, is 1/128, is 1/256, is 1/512, is 1/1024. Please tell me you've at least played the game 2048. Okay? You should at least know those, because everyone's played that stupid game, sliding those tiles around. Okay? Another way to think of this is, where's that negative? Remember the A, B, H, and K spots? No? Y is whatever my base is, I'll call it C, to the x. Remember that I have A, B, H, K. I have all of those transformation properties are still happening here. Where's that negative? It's out in front of the x, grouped with x. It's in the B spot. B was always a horizontal reflection. So it takes these powers of 2 and it just flips them. 2 to the first, 2 to the second is 4, 2 to the third is 8, 2 to the fourth is 16, and you get the creeper function is now in reverse. Now that's them rushing to find you at Terry Peak and ask who's that guy you're with. And they just kind of hang out behind the snowdrift watching you for the rest of the day. I'm not joking, it happened. So, once I have the graphs, there was a kid who was very, very obsessed with Miss McCreary. Like, oh hey, don't you drive that that blue Jeep thing that's got the rack on the top and this is the license plate number?
Oh.
Hey, I saw you at the grocery store this weekend. Who's that guy you're with? Well, I didn't see you. I know. Hey, don't you live over by so-and-so's house now? Mm-hmm. It got weird, like, ugh. So, now that I have the graphs, tell me about the stuff. Okay? This one. Say it with me. Domain, what? All real numbers. Range. Careful, where do the y's exist? 0 to infinity, will I have a parenthesis or a bracket? Parenthesis because there's a horizontal asymptote there that it does not cross. What else? Intercepts. X-intercept. No, because I cannot put 0 equal to 3 to the x. You tell me, how many 3's do I multiply together to make 0? Right? It's not possible. Okay, y-intercept though, 0, 1. Asymptotes. There's a horizontal asymptote. Ha! Y equals 0. Okay. And behavior, make sure you're saying them as limits. Limit as the function approaches negative infinity. Limit as the function approaches positive infinity. As we head all the way to the left, what we got? 0. As we head all the way to the right, up to infinity and beyond, right? Where it's increasing or decreasing? Increasing as I go left to right. Always. Negative infinity to infinity. It's never decreasing. Remember, it's as you go left to right across the x-axis. For B, it's going to be all of that same stuff. The only difference is now it's decreasing from negative infinity to infinity and never increasing. So the idea is I can graph the thing and I can analyze the thing. Which of the things shall we do? Oh, you know we're picking that one. 1C, I would like you to graph it and tell me all the stuff. Stop that.
Did you tell Lily on it? So on Thursday, I sat in the college, and the sub came over and gave me like a 15-minute lecture on it.
That's illegal.
Yeah, she was like, oh, why do you sit? And like kept asking me a ton of questions, and was like telling me all the reasons that like I should stand. It was weird.
I'll include it. Thank you. Just look at it as transformations. That +1, is that an A, B, H, or K spot? So that just tells me that horizontal asymptote moves up 1. That's it. So then I do all of my powers of 4 from there. It's going to be reversed because 1/4 to the x is the same as 4 to the negative x. Okay? So powers of 1/4 are 1, 1/4, 1/16, 1/64, 1/256, 4, 16, and you get z graph. Like that. Okay? So you can just do it by transformations if you know your powers. And then we say all the stuff. Well, we've got domain, all real numbers again, range. This time it's going to be from 1 to infinity. My x-intercept as a no-go. My y-intercept is now at 2, 0. Oh, 0, 2. There we go. What else was it? It's continuous for all real numbers. There's no symmetry. Limits have f of x, or is it h of x? H of x. As x approaches negative infinity is infinity. Limit h of x as x approaches infinity are... Oh, no, not 0. Where is it now? As I head all the way to the right, what's my limit? 1. Close. What else? Oh, intervals increase and decrease. This thing is going to be decreasing from negative infinity to infinity. Never increasing. That's it. Or did I forget anything? Okay, so we've done the analysis thing. This is just blah, blah, blah. Can you do it again? It gets moved up 1. It normally has a horizontal asymptote at 0 because I can't have something to a power make 0. I just moved it up 1. So.
Could it be like 1/4 minus this variable, like a b or a k, like not a k, but like
Oh, the base have a variable in there?
yeah.
No. If the base has a variable, now you're getting into Calc 2. If you have a base that includes a variable and a variable and an exponent, now you're getting into some really funky stuff. No, we're not. We don't do that here. Okay. So, oh hey, look. You can just say A or B, right? Again, as soon as you start doing transformations to this, moving it left and right and up and down, then all of this information changes. But this is the base information for exponential functions. They talk about growth and decay. It's pretty simple. If the base is greater than 1 versus the base is less than 1, that tells me if it's growth or decay. Notice that it says from 0 to 1. So they're kind of excluding the negatives. Because if I have a negative there, that really messes with it. I want you to think about what that looks like if I have y equals 2 to the x. What's the general shape of the graph look like? I want you to think about that in terms of plugging in points.
Or is that even to like it's not if it's odd?
2 to the negative 2 to the first. Negative 2 to the second is now positive. Negative 2 to the third. Negative 2 to the fourth. Negative 2 to the fifth. What happens when I have an x value that is not an integer? Is it odd or even? It creates a discrete function that goes Splitsville like this. It looks like an old Elmer Fudd blunderbuss. Okay, so that's why we're never going to have a base that's negative, because it absolutely messes with it. Okay, but I will say whether it's going to be less than 1 or greater than 1, growth or decay. Think about what happens if I repeatedly multiply by 2. I double it, and I double it, and I double it, and I double it. I tell you tonight, I'm only giving you one problem for homework, with the condition that for the rest of March, I'm going to double it every day. And then it's 2, and then it's 4, and then it's 8, and then it's 16, and then it's, uh-oh. So this is starting, uh-oh. Okay. Or the classic example is, what about the other way around? What if when I repeatedly multiply by a half? What happens when there's a $1,000 laptop, they have a coupon printed in a magazine, and they don't have at the bottom in the fine print, limit 1 per customer. It's a $1,000 laptop. I go to ring it up. I'm like, cool, coupon, boop, 500, 250, 125, and keep going. Will it ever be free?
No.
It'll be worth such a fraction of a penny that you could take belly lint, put it on there, and they just say, like, go away. And they just give it to you. But it won't be free because it won't actually hit 0. That's the idea of exponential growth and decay. Something getting really big, something getting really small. So, transformations. Y'all remember how transformations work? A, B, H, and K. If you didn't write it before, I want you to write it now. I'll just put it in this general area. I can zoom in. I can put it where I want. Y is, we have whatever our base is. I'm going to say C just because we're already using B somewhere else. So whatever our base is to the X. This is how I start. But then we're going to do a bunch of stuff to it. Y'all remember what A does? Vertical stretch and compression. How do I know the difference? Well, 5/2 is a fraction. Less than 1 or greater than 1. Okay. Also does vertical reflections, or reflection in the x-axis. Grouped in with the x is bass-ackwards land. What does H do? It's a horizontal translation in bass-ackwards land. If it says +5, you're going left 5. If it says -5, you're going right 5. I also have B. We've already seen that. That's going to be horizontal stretch and compression, horizontal reflections. Be careful that the stretch and compression is always by the reciprocal. So if B is 5, it's actually a horizontal compression by 1/5. Right? If I'm taking my input and quintupling it, it takes a 1/5 as long to get where I'm going. And then K is my vertical translation. Not grouped with X, not bass-ackwards. So if it says +5, I just move it up 5. If it says -5, I move it down 5. Okay. No, exponential functions will only have a horizontal. That's it. Because they're defined for all real numbers. They can't have a vertical asymptote. That's a good question. Okay. So instead of beating this to death, I would like you to, without a calculator, I want you to graph that one. Without a calculator, can you do the appropriate transformations? Tell me what the transformations are, use your powers of 4, and graph that. All right. Put. Boy, that cherry one kind of turned into a slop pile. The blueberry one did last year too. There we go. Right. I don't pie. Are rhubarb and apple okay to be left out? Or should they be in the fridge? Okay. Till next hour comes in and eats them? All right. Like legit, Grandma came up with that pumpkin pie recipe because I don't pie. So that's what I get instead of birthday cake.
More of an ice cream.
Well, I can't handle goo, the texture. So
Why can't you handle the standard nutrient base? It feels wrong.
That one's outside. It's like a -1.
Like beans. Beans don't
Yes.
feel right. Well,
They
things should
don't.
not be liquidy and solid at the same time. It's not for X.
see, I can do baked beans. I can't do refried beans.
Refried beans aren't bad.
But then I also strain the baked beans, so like all the sauce isn't on the fork. Okay. If that would be the parent function, 4 to the x, what two things will be done to it? Reflection in the x-axis or vertical reflection? Horizontal translation, left 2. So what that does, it takes this original point right here. Remember how we always have a vertex, an origination point, something like that, inflection point. Okay, that 0, 1 is kind of that for a exponential function. I'm going to take that point and move it left 2. I'm going to reflect it across the x-axis. And then I'm going to do all of my same powers. It's just they're going to be going downtown because of the reflection. And they're all going to be moved back the 2. So 4 to the 0, 4 to the first, 4 to the second is already off the map. 4 to the negative first is 1/4. Like that. Okay? Gets moved left 2 and reflected. Okay? Now, you have to know how to identify transformations. We beat the living crap out of that in Algebra 2. Can you state the transformations, have no idea how to graph it, but still graph it by points? Yeah, you can. Okay. I would hope you can graph it by transformations, but if you need to just state the transformations and then go ahead and plot by points, I'm okay. E, what?
On graphs that have a negative base, Why do they do like a blunderbuss kind of thing instead of like a just up and down and up and down?
Because you can't connect the dots. Between any 2 points, there's an infinite number of points. You're like, wait, what? Pick between 0 and 1. Can you name a point that's between there? How about 0.1? Can you name a point between 0 and 0.1? Can you name a point between 0 and 0.000000001?
Uncountable infinity.
So within a finite space, there's an infinite number of points. If that idea makes you go, ooh, instead of ow, go to Math Circle. Okay? It's once a month. It's over at BH. You can either meet there or here, and then everyone piles in the bus and heads over. Like, Math Circle's cool stuff. By the way, who went to the meeting? Who's going to do the PreCalc mathathon or whatever it is? Y'all.
Yeah, I wanted to, but I totally forgot.
Only seniors are allowed to participate in the master's level this year. That means at the advanced level, it is literally just PreCalc classes. Go do the thing. You get free lunch. It looks good on a scholarship application. You go to a competition. You hit on kids from other schools. It's great. Just go. Okay? Go talk to Spear. Or maybe they hit on you. You never know. Okay? E. Y'all remember E? Ironical that we're talking about E on Pi Day. I actually attended a Pi versus E debate before. It was hilarious. It was about which is more relevant, which one is more useful, in which one's more practical. They ended up fighting like Leonard and Sheldon, like throwing physics yo mama jokes at each other. One of them actually got mad and stomped off, like he rage quit in the middle of the debate. It was hilarious. E is another one of those special irrational numbers that happens so often it gets its own symbol. That's also why if you go back into your Algebra 1 and early Algebra 2 textbooks, they never used E as a variable because E is a number. E is the limit to a natural growth function. The idea is if something grows based on itself. Example, I'm going to start you at 10 problems of homework. And then every day I'm going to add 20% of what I added the day before. So the next day, 20% of 10. 2. I'm going to add 2 problems. But the next day, I'm going to add 20% of that.
I don't feel like doing math in my head.
I'm going to add 0.4 of a problem. And then I'm going to add 20% of that. I'm going to add 0.08 of a problem. Then I'm going to add 20% of that. 20% of a thing, of a thing, of a thing, of a thing, of a thing. Well, that's repeatedly taking times 1/5, times 1/5, times 1/5. Eventually, I'm not adding anything. Eventually, it reaches a horizontal asymptote. The limit of this function, something growing based on a portion of itself, is E. It's got a horizontal asymptote at E. So that's where it comes from. What we need to know is the word continuous. Whenever I see the word continuous, especially in context of word problems, then I'm using E because E is something that happens continuously based on itself. What you need to know is that it's a button on your calculator and it's about 2.72, the same way that pi is about 3.14. So if they tell you to graph a thing, I'm betting most of us probably don't know the powers of E off the top of our head. I know that there's going to be a horizontal reflection. I know anything to the 0 power is 1. I know E itself is 2.72-ish. So E to the second. Well, that would be about like 3 to the sixth, since 27 is 3 to the third. I'm guessing it's close to 7.29. So grab your calculator, E to the second. 7.3-ish? 7.4? Okay, so 1, 2, 3, 4, 5, 6, 7, and change. And then 1 over E is going to be very small. And then squared, and I get my graph, right? And I can say there's a horizontal reflection, or reflection in the x-axis, or y-axis. Okay? So this is why I'm saying, yeah, I want you to graph by transformations, but what happens if you don't know the powers? Can you still tell me that's a horizontal reflection and then go plot points from your calculator? Yeah, buddy. Okay. So E is just a different base. I want you to tell me the transformations and... Okay. Tell me what transformations you got and graph it. Yo.
Aren't natural logarithms logs for basically?
Yes.
Yeah.
We'll get that next week.
Oh no.
In fact, that's what started that debate, is natural logs are what's used, not log base B. In common science, we're either using common log base 10 or we're using log base E because something happens continuously.
And what was the argument behind?
Geometric formations, diameter of the Earth, lines of latitude and longitude, navigation, orbital calculations. Oh, yeah, lots of stuff. I mean, it was like 18 years ago that I saw it, so. Children destroyed my memory. Okay. Don't have to get too wild with it. I can only fit 3 points on there, and that's even if I go off-road. Well, 4 if you consider the fraction, but we know it's just going to skirt down along that asymptote again. Horizontal asymptote at 3 because it moved up 3. Name your 2 transformations, plot points by a calculator, you're good to go. And honestly, if it was anything past E squared, I don't know. I'm using the calculator too. Okay, so I don't see a need to do all of them, just a couple, like, hey, do you remember this? Here we go. So, you have gotten in several different classes from elementary school, or maybe not elementary, middle school onward, different problems that have to do with percents and interest. Okay? Now, here's the proof for it. I know y'all don't like mathese. It's really hard to read a math textbook. Okay, but the idea is, if every year I get a percent of a thing, y'all remember doing a problem, maybe in Algebra 1, maybe back in middle school, where it's like, you got $1,000 in savings, and the bank pays you 2% interest, you're not allowed to touch it until you graduate. Say you get that, grandma gives you a savings bond or whatever, just throws $1,000 in an account, starts it for you, says you can't touch it until you're graduated. Well, after 1 year, what's 2% of 1,000? $20. Okay, now you're in 7th grade. You have $1,020. 2% savings. How much do you have in 8th grade? What's 2% of 1020?
You get $20.04.
And 4 cents?
4E.
There we go. You remember doing this where you just had to keep doing that reiteration so many times? You'd have to write it out 6, 8, 10 times. And that was annoying. Well, if I do that formulaically, there we go. What I'm saying is I'm adding 1 plus the rate. But then I'm doing 1 plus the rate again. But then I'm doing 1 plus the rate again, 1 plus the rate again, 1 plus the rate again. That's exponential. When I take 1 plus rate, when I take 102% of a thing over and over and over, well, if I'm repeatedly multiplying by 102%, then why don't I just take that to a particular exponent? They combine like terms, simplify it, blah, 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 blah. You get formula. And y'all remember formulas. We like formulas. Plug and chug. Do you remember what these things stand for? Okay. The amount that I have is the principal, LE, principal meaning primary, the principal amount. No, that's AL, right? AL, primary. Okay. The principal amount, so this is what you start with. 1 plus your rate. This is the number of times it's compounded. Compounded is a fancy way to say figured out. The number of times that you're going to compound an interest in a year, you've heard of quarterly interest, monthly interest, to the number of times again, times time, typically in years. So we need to get a couple of words out of the way. If I say something is compounded weekly, how many times in a year does that happen? If I say it's quarterly, 4. Bi-weekly. I heard 104 and 26. Bi-weekly is every 2 weeks. Semi-weekly. Now it's twice a week. So now it'll be 104. Okay. So whether something is biannual versus semi-annual. That's the difference between 1/2 versus 2. Okay. So you just got to know a couple of those words before we move into these. And I do not like any of these problems. Instead, we're going to get scary. Ha 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 ha. Y'all got phones? The number of Spearfish High School students who immediately go into BH is significant. So we'll just use that as our standard example. I would like you to find out what is the annual tuition for an in-state resident to attend BH. Get your Google. Yearly tuition and fees in state. In a in-state resident.
Are we including room and meal plan or just?
No, that'll make things even worse.
I would like to make it even worse.
Okay, I hear 8672. I'm just going to roll with it. Okay, but that's per year. Let's say that you do the best possible thing. You live at home all 4 years of college and go to BH just to save money. Let's say you actually get your 4-year bachelor's degree in 4 years. Most of them take 4.5 or 5. How much money? Uh-oh. Your parents make too much money. You're not going to get any financial aid, but your parents also aren't going to pay for it because they think that you can pay for your own college working at Burger King. So we're going to say you get that whole thing on a private loan instead of federal subsidized. A typical interest rate for private loan on a college before everything went to hell would be about 4.5%. And let's say you pay it back over 10 years. Semi-annually, monthly, daily. Plug it in. Principal amount, 34,688. 1 plus. If this is compounded semi-annually, twice a year. So I know I got a 2 here and I got a 2 here. My rate, 4.5% interest. 2 places. The way that I always do it, even with the freshmen, is, do y'all remember seeing something like this? Two places. If I'm going decimal to percent, I go 2 places to the right. If I'm going percent to decimal, I go 2 places to the left. Okay? So 4.5% is 0.045 for 10 years. How much does that cost with you doing everything you can to save money? Still living at home with mom and dad for 4 years of college. It sounds about right. Anyone else confirm? 54,000 and change? 54,000 how much? Okay, if I switch that over to monthly, what changes in my formula? Monthly. I'll turn these 2 to 12. So you can just go back and highlight the formula and insert. Y'all know second insert? Insert is right above delete. Second insert allows you to put that in without typing over things. Okay. Now how much if they compound it monthly? Sounds right. What if they say daily? Now what do we do? Compounded daily. Okay. We'll turn those into 365. If you want to be facetious, call it 365.25. Let's just all use 365.
54,100.
Someone else confirm? Okay. So how come it jumped so much from semi-annually to monthly? And then monthly to daily, it didn't jump as much. What would happen if I took that same thing, what was it? 34,688? 34,688. 1 plus, my rate was 0.045. What happens if I take that daily and I go down to the hour? How much do you think it's going to move the needle? And then it was 10 years. Moved it like $1.45. What happens if I take that same thing and I take it times 60? I'm also going to go to the minute. There we go. I give you a nickel. Each time, the more times I do this, I went from semi-annually to monthly, to daily, to hourly, to minutely. I'm approaching doing it how often? Constantly. Where's another word for that? Continuously. And when I have something that is continuous, you see that this 1 plus thing over x, wasn't that where we got the limit of e? So it turns out that if I keep doing this continuously, like that, you see, okay, this is from the problem we scrapped. You see how eventually I'm not really adding much. And that's because I'm starting to approach a limit. We've talked about the law of diminishing returns in here. You can do something so many times before it doesn't actually affect it anymore. And when I do, I can take that 1 over x business and replace it with e. Hi.
I was about to ask if all of this is just like if all these like limits are multiples of e.
Ta-da. Okay, so same difference, except now it's my amount is the principal times e to the rate times time. I don't have to worry about the number of times compounded anymore because now it's continuously. And I need you to make that distinction in your notes. If it says the word continuously, you're using PERT instead. Okay? So then, over here, do that same thing. What was it? 38 something, something, something? 6. 34,688. We just cut it off there, right?
Yeah.
Okay. If I take that, e to the my rate is 0.045 for 10 years. Now if I switch to continuously, and it shouldn't be too much different than that last one we found.
Yeah, it's 54,401.
404, 401, 61 cents. Okay. Now the reason that I want to talk, I bring this up every time we do exponential functions in both Algebra 2 and PreCalc. to talk about, basically in a few short years, most of you are probably going to be in college and you're going to have to pay for stuff. This idea of continuously compounded interest does happen. Primary example, 7, 8, 9 years ago, I was in a decent spot at the time. My wife and I looked through all of our finances and realized instead of paying interest on something forever, let's just clear out savings, get rid of student loans. It was dangerous because what happens when you're living paycheck to paycheck and you don't have savings anymore, but called for the payoff quote. How much do I owe? Wrote the check, sent it in. Good to go. Not, was it 3 years ago, I was getting a bunch of collection calls. Now, I know there's the bogus ones, right? It's probably the only phone calls you actually get on your phone is, here's your vehicle warranty, you owe money on your student loans kind of junk. So I thought all these calls were bogus. Turns out they were real. In the 3 days from my check to get from where I was living to them and processed, I accumulated another 3 cents of interest. And then they kept doing late fees and penalties and interest on that. And 6, 7 years after I paid it off, they said that I owed over $300. Because continuously compounded interest does mean continuous. You need to get a payoff quote from them and have it certified in their records that this is the payoff amount. And then they put a hold note in the account. Okay, companies like to do shady stuff like that. External for-profit companies, they will buy out your federal subsidized loans. You heard of any of the seniors talking about FAFSAs getting subsidized loans, Stafford loans? Okay, those are ones where the government says you don't pay interest on this. And then a private company buys that from the government and now you owe them interest. Okay, all this stuff is going to come to you pretty quick. What I would like to do with that, give you another real world example, let's just do it down here, is let's pick on someone. Who here has the most expensive car? Who's got that car that like there is no way you paid for this, mommy and daddy spoiling you? Who's going to throw their friend under the bus? No? Okay. Snitches get stitches. Okay. All right. I'll give you an example. I had a kid about 6 years ago. His parents bought him, so 6 years ago, bought him a 2016 banana yellow Camaro. Brand spanking new Camaro. At the age of 16 as an early graduation present so that he could enjoy it during high school. Brand new Camaro at that time, we double checked, was about 45 grand. Okay? Now let's assume that parents don't have that cash just laying around and do a loan on it. I have amazing credit, and I had like 3.2% for my truck. I'm still paying it. Okay? So let's say they got really good credit. They get a really good interest rate, and a typical vehicle loan, they usually do either 5 or 6 years. So we'll say 6 years. Okay. I would like for you to find out if that is compounded. So this is the one you're doing on your own. Weekly quarterly, continuously. How much do they actually end up paying for that car? Figure it out. Now, this is very simplistic interest. As you're paying off the principal, the amount changes, but we're just using it for a little bit of context example. It's close enough.
They crashed their cars, so I didn't have to deal with their bad
But this one, my car is
My
like,
first car was a
my car is
2000.
It's like it's like about to die, but it's also like within
If I if I just want to use E instead of the other one, can I just apply the percentage to E?
No.
Darn.
Weekly and quarterly are the first formula. Continuously is PERT. That's the point of doing this. Okay, weekly. Plug and chug. How much does it cost? What? Oh, I'm still thinking of the last problem. Yes. Okay. When we go weekly, how much? $54,521. Confirm? Okay. Quarterly. Confirm? Continuously.
$54,525 and like
17. Okay. Now, again, current multiple crises notwithstanding, there's something called depreciation. Now, again, right now, the entire world is upside down. Okay? So, right now, what I would say kind of doesn't make sense. Turns out my truck, I'm going to pay it off this summer finally, I think. 5 years? 5? I can't remember if I had the 5 or 6 year loan. Either this summer or next summer, I'm going to pay my truck off. I double checked right now, my truck is worth more than I paid for it by a good amount. Like 30% more. Because, no, before inflation. Because you can't, like the simple things, it's not just the computer chips that are going into Dogecoin farms, although that is a thing. But I ain't gonna get going on crypto because you're gonna have some tech bro try to mansplain it to the class, and no. Okay. Instead, there's also something called a pandemic. You've heard about all of the container ships that are stuck in the ports off of Coast California because they literally don't have the trucks to offload them.
That's still happening?
Yes. Okay. There's all of this stuff happening, and even the small, like the electronic switch to turn on the headlights in the car, there's a shortage of that. Okay. So, yes, all the vehicle prices are completely out of whack, but assuming the last 2.5 years didn't happen, like half of this would be gone. Let's say we had a $45,000 car. You know what the typical depreciation on a vehicle was? You've heard that, like, it loses half its value when you drive it off the lot kind of thing? Okay, a car, something that doesn't have all-wheel or four-wheel drive, the first 2 years, it's like 18% depreciation. After that, it's like 12. So we'll just ballpark it and say 15% depreciation. For 6 years. They ended up paying $54,000 for that car. How much was it actually worth by the time they were done? Okay, we'll just go continuous. 45,000 e to the, my rate is now a negative 0.15. Yeah, I do. Do that by 6 years. The car is worth a third of what they paid for it. Always buy used. Like my truck, it was White's demo model. It was the one that they let people drive as a loaner when they were fixing their car. I got it for like half the price it should have been. So the reason I'm bringing that up is because you also have these written as growth and decay functions. These should look very familiar. They're the exact same thing with different letters. N sub 0. Not like Sub-Zero, Mortal Kombat style. Sub-Zero means the initial, how much you start with. The rate, the time, N is the amount. This is the one you're going to see more often, noect. Initial amount, E, your growth or decay constant time. So it's the exact same thing, they just change the letters on you. Okay? Modeling growth or decay, y'all just look at it. 1.42% annually. Is that growth or decay? Growth, because it's bigger than 1. I hope you're not packing up. We still got 3 minutes. That's rude. Okay? Whether they say growth or decline. If something is declining 6%. Okay, make sure that you have a negative for your rate. And then sometimes you are going to have to figure out what the rate is by plugging in what you know and solving for what you don't. Okay, table shows reported number of cases in chickenpox in the United States from 1980 to 2005. Hey, you know what happened in the 90s with chickenpox? We developed a vaccine. Things went down exponentially. Imagine that. Okay. I can use this to find out what my rate is. Y sub 2 minus Y sub 1 divided by Y sub 1. Please write that down. Okay. To find an exponential rate, you divide And this is the same as percent increase or decrease from back in algebra half. You find out how much it changed. 32.2 minus 190.9. You divide it by how much it originally was. And now I have a declination rate, a rate of exponential decay, that cases went down 83% over the course of the 25 years. So I will divide it by 25 years. A 3.3% drop in cases every year for 25 years. To the point where I'm curious, how many of you have actually had chickenpox? That is new. Okay? Everyone my age, I'm not that old, I'm 37. Every one of us had chickenpox, and it was friggin' miserable. Okay? Once you have your rate, dump it into the formula. We got caught up with pi. I want to make sure that you do 7 and 6 in your notes. Ha! No. Make sure you do 7 and 6 in your notes.